Hi, in this video I will be talking about Kirchhoff's rules. Um, the main idea of this video is just to discuss the rules, what are they, and how we can apply them in a diagram. So we need to learn how I can distribute the currents as a first rules, then how I can design the loop to follow the second rules, and how we can tell the voltage for every single element following the second rules, and if it's a positive or negative. And later on in a different videos, I will be start solving problems related to Kirchhoff's rules. As a start for this one, we need to learn some terminology related to our study of Kirchhoff rules. So as a start, I have here um, a circuit with a few resistors and two batteries. It doesn't matter the values of the resistance or the voltage across the battery. It doesn't matter for now. It's the matter to learn these terminology. For first, it's the junction. Junction means a point where two or more wires are joined. When I look to my circuit here, I can identify two junctions. At point B, I have a junction because I can see three wires are connected at this point. Also, at point E, I have also three wires are connected at point E. That's what we call a junction. In some textbook, you might find people use it as a node. Junction or a node, it's the same meaning, the same definition, but it just the difference probably because of the country, which one they prefer. They use the junction or the node. It doesn't matter. Now, a branch simply is a path connecting two junction. So in our circuit here, I have three branches. I have the branch here where it is connecting the two junctions here, another branch here, and also a third branch, the shortest one, the third branch here between B and E. These are the three branches where the two junctions will be connected to each other, and also the current will be flow through these branches. Okay. Now, these are the terminology we need to learn in order to discuss or describe our circuit while we're using Kirchhoff rules. Okay. Now, the first rule of Kirchhoff's rules is the junction rule. So simply I can pick any of these two junctions, B or E, all right, and apply that rule on it, which is the total currents into the junction are equal to the total currents out that junction. Okay, so in this scenario here, in this circuit, it's a raw circuit. No one distributed the current at all. I have complete control and the choice how am I gonna distribute my current, which one gonna be going into the junction and which one is going to be out of the junction. But remember, not all of them will be going in, not all of them gonna be going out. So I can say, all right, this is here, and I will call it I1 is going into my junction. All right. Now I can say, okay, I can choose that to have I2 is going out the junction. Now for I3, I can say either in or out. I still have the choice, but I will choose to make it as out. So that's I3. Now, if I want to follow the formula of the junction rule, it says the total current in equal the total current out, which means I1 will equal I2 plus I3. So I can draw this like the scenario like this. These my resistors before, and this is my junction. All right, and I said I will choose that I1 is in, I2 was out, and I3 was also out. So the junction rule says the total current in equal the total current out, which is I2 plus I3. That's out. This one is in to the junction. Okay, you might see some people write it like this. They said, okay, the total current should equal 0 at that junction. Yes, it is. I can say I1 minus I2 minus I3 equal 0. It's the same meaning for what we wrote before. Okay, so this is the first rule of Kirchhoff's rules. It's the junction rule. Total current in equal total current out. Total current in equal total current out. Please don't forget, don't put all currents in, not all currents out. And in some cases, you might have the choice to distribute the current up to you in and out the junctions. In some cases, they might be identified, one or two of them, or the three of them. So it depends on the scenario of the question. Okay. Now, this is the first rule of Kirchhoff's rules. The second rule, it's very important one as well, where it is I will be identifying a loop of my circuit. But the rule says the sum of the potential difference across the element in a loop is equal 0. So the total voltage for this resistor plus the voltage for this resistor plus this battery, that's my loop because I chose the loop A, B, E, F, A, starting from point A, going around, coming back to A again. I chose that left loop. The total voltage of all these together will equal 0. Okay, that's the definition of it. So I can simply say this. Okay, I can say, all right, I am gonna be choosing 2 loops for this circuit. Let's pick, let's see. I can say, all right, my loop will be this way. That's my loop 1. And I can say for loop 2, I will be going counterclockwise. That's loop 2. Now the total voltage for loop 1 will equal 0. The total voltage for loop 2 will equal 0. So I can say my loop 1 will be A, B, E, F, A. For loop 2, I can say, all right, it is C, B, E, D, and back to C again. Make sure when you decide your loop, all right, you need to have all the loops you chose that will be crossing or covering all the branches in your circuit. So I chose these 2 loops because I know they will be covering current 1 and current 3 in loop 1. For loop 2, they will be covering current 2 and current 3 again. So I made sure that all my loops going through all the branches, I haven't missed any branch of the circuit. Okay, so I hope that's clear. In the examples, you will see how it is really important to do that. So let's discuss how we handle the second formula. So, all right. So the total voltage in a loop will equal 0. Good. Now, in each loop, there will be a combination of a resistors and a battery. So let's discuss this in a really simple way. Let's assume I have a resistor and I have the same resistor, right? Now let's assume my current was going this way, and here my current was going the same way. And we know that the current normally goes from high to low, from high to low. But if I chose my loop to go this way, or my loop was this way, the voltage across this resistor will be positive IR, because I entered my travel direction or my loop direction. I entered from low, went out high, so it will be positive. Where in this case, the voltage across the resistor will be negative IR, because I entered, my loop entered from high voltage, where the positive side of the resistor, to the low. So I will go with the negative. Now this is for the resistors, and you can apply the current will be opposite or the similar different directions for the loop. It's fine, up to you. Now let's try it. If I have the battery here, I have my battery, and I have also my battery. Sorry. Now my travel direction or my loop direction was this way, and in here was the other way. Okay. Now the voltage for this battery, I am coming from low to high. I will have a positive voltage, whatever the value of this battery voltage. Where here I am entering from high voltage or high potential to low potential. The voltage across the battery here will be, sorry, let's make this clear, it's a positive, where here it's a negative voltage. All right, so you distribute the current for the first rule. You decide the loop direction for the second rule. For the first rule, you need to remember the total current in equal total current out. But for the loop, the total voltage in one loop equals 0. But also you have to be careful about the direction of your loop or your travel direction within that loop. And while you're crossing these elements, the resistor and the battery, are you going the same direction of the current or opposite the direction of the current through the resistor? Are you going in the same direction of the battery or opposite the direction of the battery? That will determine the voltage of these elements, whether they are positive or negative voltage across that resistor or across that battery. And based on that, you will be able to write an equation for the voltage across loop 1 or loop 2. And you need to stick with the loop direction you decided or it's already been given to you, whether it's clockwise or counterclockwise. You start from certain point, you go in a loop and come back to the same point. All right, I know it's lots of details about Kirchhoff rules, but in the next videos, I will try my best to provide maybe 2-3 videos related to Kirchhoff rules with examples. And in every single example, I will reinforce the ideas of the positive and negative voltages across these elements, and also definitely the first junction rules. I hope you find this video useful as a start with Kirchhoff rules, and we'll practice more with other videos. Thank you.